Alright, Physics 184. Doing some more Mastering Physics on Chapter 28. This is question 13. And the problem is given, what value resistor would discharge a 2.8 microfarad capacitor to 20% of its initial charge in 2.6? So, we're just trying to find 20% of the original charge. So Q is going to be equal to, Q naught. It's going to be equal to Q, right? That's the charge, the original charge. But Q, we want that to be equal to 0.2 of Q, right? Because the initial charge is Q, but we want to get to 20% of its initial charge. And then the capacitor is going to be 2.8 e to the negative 6 farads, which I said earlier, that's Coulomb squared per joule, but 1 joule is equal to V times C, so the coulombs cancel, but we still have 1 coulomb left, so it's actually C over V. Okay. So now we can use the equation as we used before. Q is equal to Q naught e to the minus time over tau, which is just RC. And then let's go ahead and we have the time. That's 2.6 e to the minus 3 seconds. So we're looking for the value of the resistor, which is R. So let's solve this in terms of R. So to get this equation in terms of R, we're just going to divide both sides by Q naught and take the natural log of both sides. That's just going to give us natural log of Q divided by Q naught. That's equal to minus T over RC. Now, we just have to multiply by C and divide by T, or multiply by R, and we can just move this to the other side. So now it seems that's the easiest way probably. So R is equal to minus T over C times by 1 over the natural log of Q divided by Q naught. Let's go ahead and plug and chug. So we have R is equal to minus T, that's just 2.6 e to the minus 3 seconds. And then we have coulombs, which is 2.8 e to the minus 6, not coulombs, that's a coulombs, I meant capacitor. That's coulomb per volt, that's a C. Times about 1 over, let's see, 1 over natural log, this is going to be unitless, so it's just going to be Q, which is 0.2 Q divided by Q, so the Q's cancel, so it's just natural log of 0.2. So we can get R is equal to, if I type this in the calculator, we're gonna get 0.5, let's see here, did I mess something up? I'm pretty sure I messed something up. I got the same as 0.577, but it's obviously 577. So let's see what we messed up here. Micro, that is definitely minus 6. 10 to the minus 3. Looks good to me, so let's take a look again. So natural log is 0.2, 1 divided by that. So 2.6 e to the minus 3 divided by 2.8 e to minus 6. Okay, looks like I just typed in the wrong number, guys, but we did indeed get 577 ohms. I remember 1 ohm is 1 V over A. Let's just do the units real quick. And then we have 1 amp. That's equal to 1 coulomb over seconds. and then 1 volt. Let's see here. So it's just going to be, if we multiply this out, right, it would just be the V over Coulomb seconds here, right? So let's see if this matches up. So we want this to be Coulomb over second. So if we flip this to get this in the bottom, this will equal to 1 V over C over S, and that equals to 1 V over A. And that's how we get ohms. Okay, that's a little tricky math, but if you rearrange it, it'll work out.